page 7, yesterday we have learned how to diff, how to apply the rule. So x to the power of n, if we diff that is n in the front, and then the power will be reduced by 1. It's just the variable, okay? What we're focusing on is the variable. We don't care about the number itself. We just see what's the power of the variable. And this next important thing is we can't have function times with function divide by any function. We must have everything with a single term x and or plus or subtract between each other. So the only form I can differentiate is this. The only form I can differentiate is like this. Any times anything, even is x plus 1 to the power of n, I can't differentiate. Okay, I can't differentiate. It must be a single x with a single coefficient. I can times the coefficient in the front. I can make it 2x to the power of something. That's fine. But anything that looks like this will not work. So you need to have something exactly looks like x to the power of n. N can't be the denominator. I can't times it. I can't plus anything in the end of the power. So therefore, if we look at, I have go through the example A and B with you already. So if you look at C, that's a function times with a function. So that doesn't work. If that doesn't work, I need to first, you need to first rearrange the equation until you can differentiate, until you can find the gradient function. So what I'll do is still y. You not differentiate that yet. You're just expanding equations. So this is called 2x squared plus 4x minus 3x minus 6. So further, just simplify. That's minus x plus x and minus 6. So this form is good enough. It's a single x to the power of n. Single x to the power of n. Then I can find derivative. It's a good form to find derivative. So dy dx equals to 4x plus 1. 4x plus 1. Any questions? Constant becomes 0. Well, this one I have done that. I need to flip the x up. I can't have x on the denominator. I need to have x to the power of something. So it's to the power of negative a half. So what we will do for the next one, I need to use similar idea. Well, a lot of you actually just diff the top, diff the bottom, and divide it. You forget about what I said. When something divided by something, you cannot find the derivative directly. So what I will do is, and you don't know where to add bracket. The numerator needs to be in the bracket because it's this thing together, divide by 4 times that. So when I flip this up, I need to times with a quarter t to the power of negative 2 over 3. You need to times with a quarter because 4 is the denominator. So I will times by a quarter. When I put this t up, well, here, this we have is t2 over 3. Therefore, you flip it up, it will become negative. So it's negative 2 over 3. After that, well, it's still not good because it's something times something. It's not just plus and minus between t. So I can expand them as well. I can expand that. It's a half t3 minus 2 over 3 plus 3 over 4 t1 minus 2 over 3 and minus a quarter t to the power of minus 2 over 3. So we times the same base, we add the power. So 3 minus 2 over 3, 1 minus 2 over 3, and t to the power of negative 2 over 3. And then I can rearrange that. Anyone got any questions? You can ask me. That's 9 minus 2, 7 over 3. Here we have 3 over 4 t to the power of a third. And then we have minus a quarter t to the power of negative 2 over 3. So after I flip it up, expand it, I have a good form. I have a good form. There's also other ways we can do this. What's the other way I can do this? I can do 2z equals to 2t over 3 over 4 times t2 over 3 plus 3t divided by 4 times t to the power of 2 over 3 and minus 1 over 4t to the power of 2 over 3. You will have the same result. You can separate that, like every single term on top, divide by the bottom, and then you can use 3 minus 2 over 3, 1 minus 2 over 3, and t flip up is negative 2 over 3. You will have exactly the same result as here. As here. So now is a good form to diff it. So we have dz dt. Okay, the notation is dz dt. dz dt equals to 7 on 6 t to the power of 7 over 3 minus 1 plus 3/4 times a third times t to the power of a third minus 1. And then we have, okay, the minus and minus becomes plus, is 1/4 times 2 over 3 t to the power of negative 2 over 3, and then further minus 1. I can rearrange after that. You don't need to write the answer in one step. You can just go step by step. So dz dt equals to 7 on 6 t to the power of 4 over 3 plus, well, the 3 and 3 becomes 1, and that's 1/4 t to the power of minus 2 over 3. And then plus, that's half, so that's 1 on 6 t to the power of minus 5 over 3. That should be the final answer. Okay, that's all what we have done so far. We flip it, expand it, make it into the form like eligible to differentiate, and there's all plus and minus now. Then we're trying to diff it. Bring the power down and then reduce the power by 1. Okay, next one. This like is nothing difficult for this question, but it's the notation. Okay, it's the notation. What this notation means? This notation means this is the instruction. Okay, this is the instruction. Instruction of doing what? Instruction of diff that function. So overall, this means the gradient of that function. So you can directly write that equals to, and you start diff this function here. So this notation is the same as what we have in the calculator. So let's diff it first, and then I will show you this in the calculator. What we have here is 4x to the power of negative 1. Okay, for this term is 4x to the power of negative 1. I can't have x on the denominator. So the derivative is 9x squared plus 4x to the power of minus 2. And the 1 just becomes 0. So we have 9x squared plus 4 over x squared. Okay, tell you something really cool in the calculator. I'm not sure if you have learned this topic already, like before school. You know, like there's a diff sign here. Okay, see, it should be this one. Like near the button 9, there's something we can open that, and then the second last one of the second row is the diff sign. But we can get this quickly. Okay, so how we can get that quickly, that sign? So I want to diff something. I want to find the derivative. I can go shift and minus. I can directly call this sign out. I don't need to go inside that and then find it. So I can go shift minus. That's the diff sign. Okay, you can track that. It's just a really like convenient function on the CAS calculator. So it's shift minus. Okay, we have that sign. So I can just type, it's exactly the same thing as what we have here. So I will just type that into the CAS. D dx of 3 times x cubed plus minus 4 over x plus 1. Okay, so what I want to say here is this bottom variable should be the same variable as inside. If I have variable t inside, I will do d dt because that's something I enter by myself. So this variable here must be the same as the variable given in the bracket. So you diff according to which value. So it should be the same. So if I press enter, we have the same thing as what we're doing. So that's the instruction, tell you to differentiate that. Alright, for example 2, for each of the following of the curves, find the coordinates of the point on the curve which the gradient of the tangent have the given value. So I need to first find the gradient function. So f dash x equals to 3x squared for this function. And I want my gradient equals to 9. So I have 3x squared equals to 9, x squared equals to 3, and x equals to plus minus root 3. Okay, plus minus root 3. And then I need to find the y value. This is only the x value of the coordinates. If I'm going to find the y value, that's f root 3. Okay, f root 3. So is 3 root 3 plus 2 for that one. And for f negative root 3, I have negative 3 root 3 plus 2. So the coordinates I have is root 3 comma 3 root 3 plus 2 and negative root 3, negative 3 root 3 plus 2. Okay, I checked yesterday, everyone get that question, I think. This is a quadratic. I want to know the gradient equals to 0. Which point do you think gradient is 0? For quadratic, which point gradient is 0? Turning point. So I can just complete square here. That's minus 4. Well, I just using another method. You should go derivative, but I can see really what the point should be. The point should be 2, 2. Okay, that's the turning point. So the gradient must be 0 on that graph. But anyway, I will do the correct method. dy dx is 2x minus 4, and I want dy dx to be 0. X will be 2, then y will be 4 minus 8 plus 2, and y, that's a minus 2, and y equals to minus 2. So I have 2 minus 2 by using the derivative method, or I can use by completing square. I know the turning point must have gradient 0. But that only works for quadratic. Yeah, that only works for quadratic.
I don't know. Sorry, how did you do it the first way? I don't understand. Why.
Turning point. Turning point's gradient must be 0.
Oh, right.
Yeah? 0. The gradient must be 0. So I'm just completing square, find the turning point form, and I find what's the turning point. So that point, the gradient is 0. So that's just the first way. Okay, next one. Gradient equals to negative 12. I have g dash x equals to negative 3x squared. And then negative 3x squared equals to negative 12. X squared equals to 4. X equals to plus minus 2. So g2 equals to 4 minus 8. That equals to negative 4. G negative 2 equals to 4 plus 8, that equals to 12. So what I have is 2 negative 4 and negative 2 12. That's the 2 point. I have the gradient negative 12. If you think about the graph, and this is a cubic function, so it's a graph like this. Well, it's not really accurate, but that's about the point 2. That's about the point negative 2. And if you sketch the gradient, it's something like that. So they are parallel to each other. Therefore, you have gradient negative 12 and negative 12. Sorry, I draw it wrong way. It's negative. It's decreasing function. Decreasing function. So I have this. Okay, 0, that's the stationary point reflection. Okay, that's the tangent at -2 and 2, so it's -12. It's not really accurate. I'm not drawing to scale, but that's the idea why I can have two different points with the same gradient. They are like parallel. Okay, after you sketch the gradient, they are parallel to each other. That's C. Let's not do example 1 first. Let's do example 3 first. Find the derivative for that. Well, it's easy to find the derivative for that. Fx equals to 2 times x to the power of -1/2 2 times x to the power of -1/2 plus x to the power of -5/4. Okay, power first over the root. Okay, the root. So that's how I will make this function becomes 2 first. Now is alright to derive. So it's 2 times with -1/2 times x to the power of -3/2 minus 5/4 times x to the power of -5/4 minus 1. It times the coefficient and then reduce that by 1. So f dash x equals to minus x to the power of -3/2 minus 5/4 times x to the power of -9/4. I can leave my answer like that. I don't need to make it back to the positive power. I can just leave my negative power like this. Unless the question asks you do not leave negative powers and you need to make 1 over x to the power of 3/2. Otherwise, it's in a good form. Well, the last one. Well, this one I can use this method to. It's the same question as the dz dt one. It's the same as the dz dt one. I can do this. I can separate by this method. Okay, so 3 divided by x cubed plus x divided by x cubed. That's 3x to the power of -3 plus x to the power of -2. Because bottom you will have 2. Okay, bottom you have 2, so it's -2. So f dash x equals to -9 x to the power of -4 minus 2 x to the power of -3. Can make -9 over x to the power of 4 minus 2 over x to the power of 3. I can do that. Okay, that's the derivative. Or the other method I can rearrange it is fx equals to 3 plus x times x to the power of -3. And then you expand it. That equals to 3x to the power of -3 plus x to the power of 1 minus 3. So you will have the same result here. So I can use adder method. Okay, going up to example 1. Just revise first principle again. How to use first principle to find the derivative. Well, you know that's x to the power of -1. The derivative should be minus x to the power of -2. That's what I should have in the end after using first principle. So if it's first principle, I will write f dash x equals to lim x approaching h approaching to 0, fx plus h minus fx over h. Okay, over h. So what I have is this equals to lim h approaching to 0. Fx plus h is 1 over x plus h minus 1 over x, then over h. Then that's lim h approaching to 0. Well, on the numerator, what I will have is x times x plus h. Then we have x, that's my x, minus x times x plus h. I have x plus h here. And then all of that needs to be divided by h. So I will times by 1 over h. I'll times by 1 over h. So what do I have here is lim h approaching to 0. Numerator is x minus this times 1 over h. What do I have for this? This becomes a minus h. X minus h. So I have a minus h on the numerator. Well, then I can further do minus h and h becomes a minus 1. That just becomes a 1. So what I left on top, that's not good, the color. That's a minus 1, that's a 1. Okay, we divide by h. The minus h and the h will cancel each other, become a minus 1. So what I have is lim h approaching to 0 minus 1 over x bracket x plus h. That's what I have here. Okay, I think a lot of you forget what we learned at very beginning, like our second lesson. I said when you can substitute, you substitute. I can't substitute here because my h is the denominator. If I sub h equals to 0, that becomes 0 for the denominator. So that's why I cannot. I need to keep simplify. But some of you after that step, like still a little bit worried, like can I substitute? Well, the answer is why not? If you try to substitute that in, your denominator won't be 0. Everything's good. So I can substitute directly after that step. What I want to do is not get rid of the h from every denominator. That's fine to keep something on the denominator. But as long as it's not becoming 0, then we can substitute. So in this case, I can substitute h equals to 0. What I have is minus 1 over x squared. And you can see that's minus x to the power of minus 2. That's the same result as what we will have by using the direct rule. Okay, by using the direct rule. So that is correct. It's just another practice to use first principle. Yeah, just to use first principle. Alright, any other questions? If no, next Tuesday we'll just keep going for the next exercise.